Question 2. So I think it's a little memory prompt for plotting y equals ln x. Remember what the inverse function y equals e to the x looks like. So this just looks like any exponential function. It's a curve reducing like this. It goes through 1 because anything to the power of 0 is 1, and then in the minus x values it gets closer and closer to the x-axis. It's never quite reaching it, so the x-axis is an asymptote. Now y equals ln x is the inverse function of this, so it is this reflected in the y equals x line. So that gives us this. So it's just bending, curving this way, no longer through 0, 1, it's through 1, 0, and our asymptote is no longer the x-axis, it's the y-axis. So it's that curve there. Now we're trying to do the module of this. So starts off the same, so all the way down to here it's the same. However, before we plot the y value, we take the module of whatever x value is being thrown up. So whereas here we're getting minus values thrown up, before we plot it we take the module of this. So this bit of curve here just becomes the positive versions of this. So this bit here is reflected in the x-axis, so just going up there. So that's why that curve looks like that. Now for part 3, this is just straight out of GCSE. Inside the bracket affects the x value and does opposite to what you would expect. So we're going to add +4 to all the x values. Outside the function affects the y values as you would expect. It just changes all the y values, so changes the signs of the y values. So we're adding. So firstly we're adding 4 to all the x values, so the asymptote of the y-axis just shifts over 4 to the line x equals 4. Our intercept on the x-axis of 1, 0 shifts 4 to the right is 5, 0, and then so that's affected all the x values, and now we're just simply reversing all the y values. So this goes down here, this goes down here, this goes down here, these go up here and go up here. So it is a reflection secondly in the x-axis, so shifted 4 to the right and a reflection in the x-axis.